Hello students, today we are going to discuss the chemistry question paper, PTM2 chemistry question paper. We'll start with the question number 26. So which of the following has the most acidic alpha hydrogen atom? Students, generally minus M and minus I group increases the acidic character. You just come to the case of the first option. First option is having a aldehyde functional group. And come to the case of the second option. The second option is having a ketone functional group. And come to the case of the third option. Third option, it is having a ketone functional group and ester functional group. In the case of the fourth option, this is having ketone and aldehyde functional group. Students, minus I just said minus I increases, acidic character increases. In the case of the first and second options, there is only one functional group, but in the case of the third and fourth options, there is a two functional groups and both are the minus I functional groups. Here, the strongest minus I functional groups are, you can observe in the case of the ketone and aldehyde, they are the strong minus I groups. We can expect here there is a most acidic hydrogen atom. Next, we'll go to the 27th question. So, what is the 27th question? So, which is the incorrect order of the stability of the reaction intermediates? Come to the case of the incorrect order of the stability of the reaction intermediates. The first option, that is a methyl carbocation, is less stable than the primary carbocation, that is less stable than the secondary carbocation. This is absolutely correct. So, methyl carbocation is less stable. After the methyl carbocation, primary carbocation is more stable. After the primary carbocation, secondary carbocation is more stable. After the tertiary carbocation is more stable. He is asking the incorrect in the question. Come to the case of the option B. Option B, that is methyl radical is more stable than the methyl radical is less stable than the primary free, so primary free radical. So primary free radical is less stable than the secondary free radical. Secondary free radical is less stable than the tertiary free radical. So this is also given correct. Come to the case of the option C. In the case of the option C, he given the carboanion stability. Methyl carboanion. Methyl carboanion is methyl carboanion is more stable. We can observe there is some print mistake in the option C. It should be actually, if it is ethyl carbanion, that is fine, but between the methyl and CH2 minus, so there is a greater than symbol is there. Methyl carbanion is more stable than the primary carbanion. This is more stable than the secondary carbanion, and this is more stable than the tertiary carbanion. So students, come to the case of the option 4. In the case of the option 4, so that is allyl carbocation is more stable than the benzyl carbocation. Students, you come to the case of the benzyl carbocation. Actually, in the case of the benzyl carbocation, so there is a more number of the resonating structures are possible. So if you see, these are all the possible resonating structures for the benzyl carbocation. But come to the case of the allyl carbocation, students, allyl carbocation, very less number of the resonating structures. So from this we can conclude this is a incorrect option, that is option D. Next comes to students 28th question. Which of the following is the most stable resonating structure? So there is a four rules are there to find out the most stable resonating structure. First of all, neutral molecule is more stable. So after that, we can just take the positive charge on the electropositive atom and negative charge on the electronegative atom, and we can see the octet number of electrons. All these conditions we are going to see. And if there is a charge separation, if the charge separation distance is maximum, that is less stable. If the charge separation distance is minimum, that is more stable. So come to the case of the option A. In the case of the option A, so positive charge on the carbon as well as negative charges on the carbon atom. Come to the case here, negative charge on the electronegative nitrogen atom. Negative charge on the electronegative nitrogen atom. Sorry, negative positive charge on the electronegative nitro. So positive charge on the electronegative nitrogen atom, students, and negative charge on the electropositive carbon atom. Come to the case of the option C, positive charge on less electronegative nitrogen and negative charge on more electronegative oxygen. In the case of the option D also, positive charge on the less electronegative carbon and negative charge on the more electronegative nitrogen atom. Sorry, more electronegative oxygen atom. Students, option C and option D. So how we can differentiate? In the case of the option D, on the carbon only 6 electrons, but in the case of the option C, for the nitrogen atom this is 8 electrons. For the oxygen also there is a 8 electrons. It is satisfying the octet configuration, and negative charge on the more electronegative oxygen atom and positive charge on the less electronegative nitrogen atom in this particular resonating structure. So option C is the most stable resonating structure. Most stable resonating structure. Next comes to students 29th question. Consider the following compounds. So they given, so ethanamine, 2-cyanoethanamine. Next 2-chloroethanamine. Sorry, 1-cyanoethanamine, 1-chloroethanamine. You can write the option B as 2-amino propane nitrile. 2-amino propane nitrile. Come to the case of the option D, N-ethyl ethanamine. So students, here secondary amine. So plus M and plus I groups increases the basic nature of the amine, and my basic nature of the amine as well as the organic compound. Minus M and minus I group increases the acidic character. So come to the case of here, actually you just take this secondary amine. Secondary amine is more basic than the primary amine. Here both are plus I groups. After that, one chloroethanamine, one chloroethanamine. This is a weak minus I group. And come to the case of here, this is a strong minus I group. Come to the case of this option 2. Next question. Hyperconjugation in which of the following compound? So hyperconjugation occurs in which of the following compound? Students, if you take the option A, in the case of the option A, there is no alpha hydrogen. There is no alpha hydrogen to the sp3 hybridized carbon. Come to the case of the option B. Students, there is a sp3 hybridized alpha carbon adjacent to the sp2 carbon. So come to the case of this one. Hyperconjugation is possible. But come to the case of the option C. In the option C also, hyperconjugation is not possible. Why in the option C hyperconjugation is not possible? Here also there is a sp2 hybridized carbon. Actually, for undergoing the hyperconjugation, so sp3 hybridized alpha carbon with at least one hydrogen atom is required. Even in the methyl carbocation also, so there is no any adjacent carbon atom and alpha hydrogen. So here also hyperconjugation in both C and D also not possible. Next comes to which of the following behaves like both electrophile as well as nucleophile? Students, if you take ethane nitrile, in the case of the ethane nitrile, here pi electrons are shifted to the electronegative nitrogen atom. When the pi electrons are shifted to the electronegative nitrogen atom, so on the carbon there is a positive charge, on the nitrogen there is a negative charge. So here carbon positive charge acts as electrophile, nitrogen negative charge acts as a nucleophile. Come to the case of the option D. Students, here there is a double bond which is pi electron cloud existing between the two different electronegative atoms, carbon and oxygen. So pi electron cloud which is delocalized towards the electronegative oxygen atom. Here carbon is having a positive charge and oxygen is having a negative charge. So oxygen acts as a nucleophile and carbon acts as a electrophile. 1 and 4. 31 question. It's very simple question. Next, come to the case of the correct order of the acidic strength of the compounds. Come to the case of this correct order of the acidic strength of the compounds. Students, here actually there is a alkyne, there is a alkene, and for the alkyne, how many acidic hydrogens are there and minus I groups are attached? What is the relation between the percentage of S character and electronegativity? So percentage of S character is directly proportional to the electronegativity. This is directly proportional to the acidic character. So if you take chloroacetylene, so chloroacetylene, this is acting as a stronger, so good minus I group. After that acetylene, here there is a two hydrogens, two terminal hydrogens are there. So two terminal hydrogens which is attached to the electronegative triple bonded carbon. So this is more acidic than propine. In the case of the acetylene, there is only one hydrogen attached to the triple bonded carbon. But in the case of the propine, there is a acetylene, two hydrogens are attached to the triple bonded carbon. But in the case of the propine, only one hydrogen is attached to the triple bonded carbon. So that's why propine is less acidic when compared to the acetylene. Come to the case of the ethylene. Students, in the case of the acetylene, this is having a sp hybridization. The percentage of S character is 50%. In the case of the ethylene, sp2 hybridization, the percentage of S character is 33.3%. So here option D. 33, very nice question, students. But he just given in a graphical representation. You just come to the case of the cyclopropynyl carbocation, cyclopropynyl carboanion, and cyclopentadienyl carboanion. First, come to the case of the cyclopropynyl carbocation. So here it is having sp2 hybridization, sp2 hybridization, sp2 hybridization. So 4n plus 2 is equals to 2 and 4n is equals to 0. Students, as we learned in the Haeckel's rule, n value can be 0, n value can be 1, or n value can be 2, n value can be 3. So, and the molecule is planar, then it is satisfying the Haeckel's rule and it is aromatic compound. So, cyclopropynyl cation is a aromatic compound. Come to the case of the cyclopropynyl carboanion. Cyclopropynyl carboanion, here also all the three carbons are having sp2 hybridization. 4n plus 2 is equals to 4. 4n is equals to 4 minus 2. So n is equals to 2 by 4. So this is fractional and it is anti-aromatic. Anti-aromatic. The first one is aromatic. Come to the case of the cyclopentadienyl anion. Cyclopentadienyl anion. Here the carbon atoms are having sp2 hybridization. So 4n plus 2, which is 6. 4n is equals to 6 minus 2, n is equals to 4 by 4. So this is 1. So this is aromatic. This is aromatic. Students, generally you come to the case of the stability. Aromatic is more stable than non-aromatic. Non-aromatic is more stable than the anti-aromatic. Here cyclopropynyl carbocation is aromatic and cyclopentadienyl carboanion is aromatic. 5-membered ring is more stable than the 3-membered ring. And most important thing, energy is inversely proportional to stability. So which is more stable, that is having a less energy. Which is less stable, that is having a more energy. Students, you just come to the case of the given graph in the question. If you observe the second option, third is having a less energy, and the second, which is aromatic, that is having a more energy. Okay, so here very clear. So third one is having more stability. If it is having a more stability, definitely that is having a very less energy. After that first, after that second. So it is inversely proportional to the energy. So anti-aromatic compound is having a more energy. Next, which of the following compounds is most acidic? Which of the following compounds is most acidic? Students, suppose the H plus ion is removed. So H plus ion is removed here. This is going to form cyclopentadienyl anion. Just now we discussed in the previous question. So here 4n plus 2 is 6. 4n is equals to 4, n is equals to 1. So here, students, it is satisfying the Haeckel's rule and the compound is aromatic. So come to the case of the option D. Suppose if the H plus ion is removed. If the H plus ion is removed, so 4n plus 2, which is 8. 4n is equal to 6, n is equals to 6 by 4. So this you are getting the fractional. So this is not aromatic. So after the reaction, if the compound is going to attain the more stable, so that particular reaction is possible. I said n number of times. Okay. Here, always the reaction is occurring to form a more stable compound. In the 34th question also, cyclopentadienyl anion. So aromatic carboanion is formed which is more stable. Next question, 35 question, which of the following carbocation is more stable? Come to the case of the which of the following carbocation is more stable. Students, if you observe the one, so here this is a triphenyl carbocation. Students, a triphenyl carbocation, definitely this will be more stable because of the more number of resonating structures. More number of the resonating structures. Come to the case of the second one. So that is a diphenyl carbocation. It is also having a resonating structures, but the number of the resonating structures is less when compared to the triphenyl carbocation. And come to the case of the cyclopenta pentenyl carbocation. Here there is no resonance, students. There is a possibility of the hyperconjugation. Even in the this butyl fourth one, there also hyperconjugation, alpha carbon, alpha carbon. So come to the case of the first structure, it is having a more number of the resonating structures, that is triphenyl carbocation. It is more stable. Next 36 question, students. What is the correct relation among the 1, 2 and 3? So come to the case of the correct relation among the 1, 2, 3. Students, here you see, observe it very carefully. Pi electrons are delocalized to the electronegative oxygen atom. So pi electrons are delocalized to the electronegative oxygen atom. So nitrogen lone pair of electrons generally carbocation. If the lone pair of electrons and carbocation is on the adjacent atom, lone pair of electrons is moving towards the carbocation and stabilizing. You are getting so students 3 is a resonance structure of 1. 3 is the resonance structure of the 1. 37 question. The correct decreasing order of the stability of the ions. The correct decreasing order of the stability of the ions. Students, here just now we had a discussion in the previous question. If the lone pair of electrons and positive charge is on the adjacent carbon atom, so lone pair of electrons is shifting towards the positive charge and it is stabilizing by the resonance. Come to the case of the structure 1 and structure 3. Actually, here the given carbocation can be stabilized by the hyperconjugation. There is a 5 alpha hydrogen atoms in the case of the structure 1. In the case of the structure 3, students, here there is a methoxy group This methoxy group acts as a minus I group, students. So minus I group destabilizes the carbocation. Minus I group destabilizes the carbocation. So obviously 2 is more stable than 1 and 1 is more stable than 3. Next question, students, 38 question. Which of the following is a highly stable carbocation? Students, just now we discussed plus M and plus I groups. Plus M plus I group stabilizes the carbocation. Minus M and minus I group stabilizes the carboanion. You come to the case of the OCH3 is at meta position. This is a minus I group. Minus I group. NH2 is a weak minus I group, students. That is also at meta position. NO2 is a strong minus I group. So here, because of the minus I group, in the case of the option B, option C, option D, the carbocation is becoming unstable. In the case of the option A, there is no plus M group, there is no minus M group, there is no minus I group, there is no plus I group. If you make a relative comparison with the rest of the three, this benzyl carbocation is more stable. So benzyl carbocation is more stable. Next comes to which statement is incorrect about the methyl carbocation and carbene. So both serve as a electrophile. This is true, students. So around the carbon atom, in the case of the here 6 electrons are there less than 8 in the carbocation. Even in the carbene, that is 6 electrons are there. Here also this is 6 electrons. So both are acting as electrophile. In which both the cases central carbon atom possesses 6 electrons in the outermost shell. That is also correct. In both the cases, carbon is having sp2 hybridized. Yes. Here 3 bond pairs. As per the VSCPR theory, 3 bond pairs means sp2 hybridization. Here 2 bond pairs and 1 lone pair. So this is also having sp2 hybridization. Come to the case of the option D. Methyl carbocation is triangular planar. However, carbene is linear. So carbene is not linear, students. So carbene, this is also trigonal planar. That is option D. Next question, 39th question, students. Next is 40th question. I'm sorry. Salicylic acid is stronger than meta, para, isomers and benzoic acid. Salicylic acid, which is the salicylic acid? Orthohydroxybenzoic acid is the salicylic acid. So come to the case of this orthohydroxybenzoic acid, if the H plus ion is released, here students actually there is a ortho effect. So there is a intramolecular hydrogen bonding. Because of this intramolecular hydrogen bonding, okay, so salicylic acid is stronger acid than meta isomer and para isomer even when compared to the benzoic acid. Both the statements are correct. Statement 1 is true and statement 2 is also true. Next comes to 41 question. Tropone is an aromatic compound and has 8 pi electrons. Students, tropone, recently we discussed in the class also. Tropone, actually this is the tropone. Here the tropone is having a Tropone is aromatic compound. Actually, if you take a ring, in the ring there is a 6 pi electrons are there. These pi electrons are moving towards the electronegative oxygen atom. So you will get the structure. So the ring is having 6 pi electrons. Pi electrons of the carbonyl group in the tropone do not involve in the aromaticity. That is true. Statement 1 is false, but statement 2 is true, students. Next question. 42 question. Which of the following is the incorrect statement? In the case of the carbon-carbon bond length in the benzene is 139 picometers due to the resonance. Yes. So because of the resonance, the bond length is between intermediate to the carbon single bond carbon and carbon double bond carbon. Next, the difference in the energy between the actual structure and lowest energy resonance structure is called resonance stabilization energy. This statement is also correct. Two nitrogen bonds of the nitromethane are not of the same length. Actually, students, two nitrogen oxygen bonds are of the same length because of the resonance. This is the incorrect statement. And come to the case of the OH, oxyalkyl amino alkyl amino groups show positive resonance effect. This is absolutely correct. So A, B, and D are correct. The incorrect statement is option C. So option C will become the answer. Next, come to the case of the 43 question, students. This is based on the previous question, PYQ question only. Students, if you see, there is a already nitrogen is having a one lone pair of electron, okay, and between the carbon and nitrogen there is a pi electron cloud. As we know that pi electrons move towards the electronegative atom. So here this nitrogen is getting the pair extra electron pair. So the second nitrogen atom which is having a more electron density, when it is having a more electron density, it acts as a strong base. So the basic character is high for the second nitrogen atom which is represented in the question. Next, most acidic in the following compounds. So here, students, you just come to the case of the option A and option D. Come to the case of the option A and option D. So positive charge on the more electronegative oxygen atom and positive charge on the less electronegative nitrogen atom. Okay. Positive charge on the more electronegative oxygen atom is highly unstable. More electronegative oxygen atom is highly unstable. So when it is highly unstable, so definitely it is releasing the H plus ion and neutralizing the positive charge. Okay, that's why the first option is more acidic when you make a relative comparison in the given four options. Next, 45 question. Students, we studied in the ionic equilibrium chapter. If the acid is strong, if the acid is strong, its conjugate base is weak. If the acid is weak, its conjugate base is strong. You come to the case of the acidic character, carboxylic acid is more acidic than the acetylene. This is more acidic than NH3. This is more acidic than alkane. You come to the case of the conjugate base. Carboxylate ion is the weaker conjugate base than this acetylenic carboanion, than NH2 minus, than R minus. So here 45 option A is the answer. Next we'll enter into the integer based question, students. 46 question, I will say. So generally in the class also I take the question and understand the question easily, write very clearly on the paper what he is asking. Try to understand the question here. Here, number of compounds having relatively more acidic hydrogen than this isobutane, students. Students, this isobutane, for suppose H plus ion is donated. H plus ion is donated. You are getting tertiary carboanion. Students, tertiary carboanion is unstable, highly unstable. Why? Because there is a plus I groups are there. Because of the presence of the 3 plus I groups, which is destabilizing the carboanion. So that's why this is unstable. So definitely this is a weak acid. So benzoic acid is one of the strongest acid, students. Even acetone is also one of the strongest acid than isobutane. Phenol is also strongest because phenoxide ion is stable. And you come to the case of the acetone. Here acetone also, when CH2 minus, it can form the stable enolate ion. Propine. So propine, the hydrogen is attached to the triple bonded carbon. This is also more acidic. And come to the case of the benzene sulfonic acid. Come to the case of the benzene sulfonic acid, students, you know that SO3H is more acidic. And come to the case of the ethanol. Ethanol is also more acidic. It is releasing the H plus ion, giving strong conjugate base, ethoxide ion. So all the 6 are the strong acids in the given option. Next 47, students. Come to the case of the 47. Students, here you come to the case of the given structure, that is a tertiary carbocation. Tertiary carbocation. How many alpha hydrogens are there? Students, there is I am just rounding up. You come to the case of this, this is involved in the hyperconjugation. This is also involved in the hyperconjugation. This is also involved in the hyperconjugation. And these two hydrogens also involved in the hyperconjugation. Totally 6 alpha hydrogens which are involved in the hyperconjugation. 48, students. How many of the following groups show both minus I and minus R effect if attached to the phenyl ring? Come to the case of the chlorine. So chlorine is having minus I and plus M. And you come to the case of the NHCOR. This is moderate plus M or plus R. And you come to the case of the oxymethyl group. This is minus I and plus R. You just come to the case of the cyano. Yes, this is acting as a minus I and a minus R. You come to the case of the NO2. NO2, students, minus I and minus R. Even you can take the ester. Ester is also minus I and minus R. And NR3 plus. This is also minus I and minus R. Come to the case of the CCl3, minus I and minus R, SO3H, minus I and minus R. 6 is the answer. And come to the case of the 49th question. It's a PYQ imitated question. How many of the following show inductive mesomeric as well as the hyperconjugation? In the case of the first structure, there is a mesomeric effect and inductive effect. Come to the case of the second structure, there is a mesomeric effect, inductive effect, hyperconjugation. In the case of the benzene, only mesomeric effect. In the case of fourth one, there is a inductive effect. Here in the fifth structure, there is a mesomeric effect, inductive effect, hyperconjugation. Even sixth also mesomeric effect, inductive effect, hyperconjugation. Metadimethyl benzene, metadimethyl benzene here mesomeric effect and inductive effect. Come to the case of the fourth here, mesomeric effect, inductive effect, hyperconjugation. Students, here I am getting only 3. Will confirm you. Next question number 50. Among the following, how many of them are more basic than aniline? So come to the case of the more basic than aniline, definitely first one, because on the nitrogen atom lone pair of electrons involved, so not involved in the resonance. Second one is definitely not, and dimethyl aniline is more basic because of the plus I nature, and here this is less basic orthotoluidine because of the ortho effect. It is less basic than aniline, less basic than aniline. And come to the case of the here this one, because of the plus M effect, it is more basic. Here it is minus M, and this is aromatic compound, so this is also less basic because the nitrogen lone pair of electrons of nitrogen is not available. And here methoxy group acts as at the meta position, acts as a minus I group, so this is also not having. But paramethyl aniline is having the more basic character than the aniline. So totally how many are there? So totally if you see, there is only 4 are there, students. That's all about the PTM2 chemistry paper.